However, it's been actually been a bit since I've actually done this, and I'm gonna give it another shot. This is probably we'll see how long this is, but that's something I'll be discovering later. But anyways, hey Toro, it's a little bit of an intriguing setup. I mean, take a look at the probabilities right now. I mean, you can see it's a general thunderstorm risk. You might ask why, and that is a pretty solid collection. And I guess we mainly have a cold core set up across portions mid Mississippi Valley. I think um, I'm pretty much. This is a bit late, but I don't know. Given the pretty high uncertainty really regarding this, I think sort of just gonna have to see what happens overnight as warmer advection continues across, stretching all the way from the southern plains all the way up into the Great Lakes region. And so, anyways, um, taking a look at this um, large scale pattern across through water vapor imagery, and you can see mainly it's broad troughing pretty much over the western portions of the U.S. right now. We see a little short wave, pretty much right somewhere right along just to the lee of the Rockies. A lot of moisture, a lot of Pacific moisture, pretty much being drawn out. Um, see is mainly zonal flow across portions stretching from California, off the coast of California, all the way into periphery of Texas, and some pretty large scale Vormax over Colorado, and pretty much ridging over the east. This time, as they're just offshore, there is another trough, pretty much carrying a lot of moisture with it too. Have a big plume of moisture extending up into Atlantic Canada, and guess we can see MS imagery, and you can see pretty much warmer advection. The green representing that warm, moist air mass, pretty much being drawn northward. We can probably see as well with the surface map. So we'll just go to it, and see mainly southerlies over much of the southern plains right now. Decent surface low somewhere in the mid 990s, maybe lower 990s. Just to the lee of the Rockies, get that westerly, southwesterly flow. Pretty much in the lee of Rockies downwind, QG processes, and then we have a surface low that's probably going to pretty much remain right around the low 990s. Pretty much maybe deepen a little bit more to maybe the high 980s, going to around somewhere around 990. Steep gradient. We can take a look at the over. We see pretty much off the southeast high pressure. Pretty much that gradient between the high pressure and the low pressure, and that's where you get that's those southerlies. They're pretty much strong at times. Don't think there's any really headlines right now for. There might be in some spots, but I know on the Texas Panhandle where you get those southwesterlies that are dry warmer advection. Then that's basically where you see some fire issues with some wildfires, pretty much expanding pretty much exponentially. Conditions where you see low relative humidity, dry fuels, pretty much with the drought ongoing, I think, and as well with strong winds that pretty much just blows those, can easily catch on fire. There's a fire ongoing that's going to rapidly spread. But that's for another thing. We're going to take a look at NAM actually. Haven't checked on NAM actually today. So, again, we have a trough, pretty much zonal flow area, some pretty much some enhanced flow. Got a little bit of shortwave you can pronounce, but then embedded within the mainly within the flow. And we can see pretty much with time, we can see pretty much right over, we see a little bit of that enhanced flow over the four corners. That's pretty much going to amplify overnight. And pretty much can see a tiny bit of an upper level low, pretty much spinning up overnight over Nebraska, and it's pretty much extending to north and east. Decent flow actually, pretty much extending into middle Mississippi. They're around 50 knots or greater. Not bad. Could be better. Maybe extending even higher in some within those low vortexes. So decent cold core setup really. See that cold air aloft, pretty much with that mid to upper level cold air vection regimen, and I guess we'll take a look at moisture return actually, and we can see pretty much some challenges already like that. The moisture pretty much those 60s dew points. They're pretty much right on the coast of Texas right now, and this is the night, pretty much the evening before, so that's gonna pretty much spell some challenges. I think that cold air aloft is probably gonna be just barely enough. It's gonna be marginal. So pretty much that moisture doesn't really extend too much. We'll take a look at the low level jet. Actually, I didn't do that. See that low level jet pretty much strengthening overnight. The temperature gradient really you get a larger temperature gradient overnight. Decent 50, 60, closer to 70 knot southwesterly low level jet. Pretty much for that warm air action. Weakens throughout the day. Pretty much veers with time. And again, those really higher theory values really struggles to make it up north. And so yeah, we'll take a look at a sounding. I guess we'll do it like 21Z. Do one in central Missouri. We'll extend even go into far western Illinois, I guess. See what that has. Very little instability at all. Pretty stable aloft. Okay, we're going further north. Pretty cool, 45 over 45. Pretty stable at the surface. A little bit got inversion just off the surface. Pretty much the same story. Again, more reflection, that varying with height. A little bit of that. Pretty much indicative, really, of some. But they haven't really struggled to get it up north. Take a look at the wrap. And this pretty much shows your discrepancies. I can go on pivotal actually. I think the pivotal already has it loaded. Even though I think it has it loaded fully anyways, so I believe taking a look at the wrap, it is definitely a lot more aggressive compared to, it's pretty much on the contrary. See that main instability gradient pretty much setting up right along the surface low. Pretty much right to the southeast Colorado. With time, that pretty much extends north. And pretty much deepens throughout the day, it looks like. Pretty much, take a look at the positioning of the surface low. Pretty much, you see pretty much an area of divergence aloft over Iowa. In the left exit region, the jet streak. So, in turn, that's probably going to lead to some surface low deepening with time. As you can also probably see, pretty much a potent jet streak too. Pretty much a straight jet streak. Pretty much 140, maybe extending up to 160, 170 knots. In the left exit region, that's pretty favorable. And then take a look at the overall trough. Got a decent defluence. That's pretty much going to aid with that synoptic scale ascent as well. Being the left exit too. That's going to help. And with some little bit of some height falls too. That's going to enact for some as well as some warm air action. We'll take a look at the vorticity term. And we can see pretty much vortmax on the leading edge pretty much in the morning. That's probably going to be enough with that isentropic ascent pretty much overgliding over the warm front. You're going to see some pretty much some morning showers, some light steady rainfall. Maybe heavier at times within that really area of greater differential vorticity of action. And with time, the main vortex pretty much arrives. We have another pretty big wave, decent wave arriving right around lunchtime, and thereafter that might throw some concerns really. Um, with a little bit of some synoptic subsidence fall behind the vorticity max, but pretty active flow actually with those a ton of those little warp maxes within the flow. I think that's, and you can barely see those. You can see those. We can go in. Those dew points. It looks like to be right around 50, which is just enough to really get just barely enough destabilization. We can take a look at the 0 to 3 kilometer instability, pretty much right along the cold front. That we'll take a look at the surface pattern. Again, right along that little, maybe I'll take a look at sample. Take a look at what was a sample behind this. We can see a little bit of that cold front feature, pretty much over Missouri into Kansas. Might be a little bit of a dry line where you see those southwesterlies. Might be some. Let me take a look at right there. I think it's probably some like diffuse dry line. Probably some diffuse dry line, maybe some, especially with that when you see that temperature increase, a little bit of some vertical mixing, and pretty much right along that boundary, pretty much within that low level instability axis. I think that's probably the maximized potential really. Vorticity stretching. I don't. And maximize vorticity from the boundary, and that low level stretching that's going to help really. Take a look at sounding. We'll take a look at 18Z. Pretty well actually. Storm motion vectors pretty much close to perpendicular. Let's take a look at those shear vectors. 22Z. Pretty much the same story, not surprisingly. So yeah, it is okay. So moving on, we'll take a look at a few soundings. We'll extend pretty much right around that instability bullseye right there. Take a look at cold temperatures aloft. Pretty much some weak flow aloft. Though there's going to probably have some, because of that really weaker storm relative inflow layer, storm relative inflow. Gonna be probably seeing some mini supercells, especially within that triple point. See some maximized vorticity augmented from maybe surface low in the nearby boundaries like the warm front and the cold front. I think probably some localized areas where you can probably see some land spouts, perhaps maybe a little bit of a brief tornado, but let's take a look at further south. This is further south. You can see decent flow aloft. A lot better shear really though. Storm relative inflow 30, pretty much mean around 31 knots. Again, these are probably going to be more smaller, low top supercells. We can see those. And quite dry aloft even. Just sort of note that, especially with this sounding. This is pretty much down in Missouri. It's definitely going to probably hurt. Even though flow is stronger aloft, I think really because of that really skinny instability, I think that might spell some issues. And again, pretty much been denoting really this pre-curved photograph. Again, not really particularly as dry, pretty skinny though. I think really updraft strength really And overall width is probably going to be, we're probably going to be seeing some pretty small supercells. And this is pretty much right around the Iowa, Illinois, Missouri triple point. And I think that's probably the conditional place really where you can see a little bit of area, maybe of some stronger forcing just from the local boundary. And I think we could probably pronounce it more in the HER. That's what we're going to look at. 18Z HER. Take a look at surface pattern. Then we'll probably close it out with the href. We'll see what it shows. Not going to really look at simulated reflectivity. Don't think it really handles too well. And again, we can see a little bit. Probably looking at dew point really. We can see a little bit of a dry line bulge right there. We can see that dry punch right there, and extending right into northern Missouri. Pretty much, that might be an area really of some localized enhanced boundary lift, and that might be enough to really get some supercells really initiate one or two. They're gonna be mainly these are gonna be mainly discrete in nature. They're going to be probably pretty isolated in nature due to the mainly weaker forcing really in place. And we can see, looking at the low level instability axis again, 3 cape pretty much extending probably between 200 to 300 joules per kilogram. That local boundary, of course. We can take a look at the vorticity. Take a look at Iowa. I haven't shown Iowa that much love. And you can see pretty much that maximized. You can see that surface low, and pretty much a little quarter in eastern Iowa, just south, just around the Cedar Rapids area. We have that combined low level instability with that low vorticity from that warm front, or potentially the warm front, the cold front, some local boundary, and that's going to pretty much aid. This instability axis is kind of skinny. I think we didn't look at storm motion vectors. Well, we did. We'll take a look at them actually. I don't need to look at something. So, pretty much generally around 20, 30 knots, pretty much to the northeast. I think for the northeast, they're probably generally, even though it sort of just cuts off with northern extent with the instability axis, I think probably that sweet spot pretty much is right around the Cedar Rapids area and points just to the south and east. That's pretty much the area where you can probably see a supercell that could probably potentially sustain for at least a few hours right before dark, before probably gradually becoming elevated due to the decoupling of the boundary layer. But actually, I did not do this. We'll take a look at it last, I guess. But anyways, I guess, and we see pretty much that evolution, pretty similar. We see that little speed max, pretty much that little area of enhanced flow, pretty much over the four corners right now. That's pretty much gonna eject northeast where it's been up in this full blown shortwave. That's gonna eject northeastward with time tomorrow, and pretty much we're gonna be seeing that. Take a look at. We'll probably expand this a little bit, or maybe zoom it in a little bit, and take a look at the. Take a look at the surface-based instability. We'll take a look at the mean. Not expecting it to be too high. I think the HER and the RAP are probably the two more aggressive solutions. And yeah, they pretty much are. You can see generally right around 100 joules per kilogram is the mean. Maybe a little bit greater than that. Not surprised. The minimum is none, and the max is actually like 1,000 joules per kilogram. Which is a little bit interesting. We can also see some timing differences. You can probably see probably the faster solution where you can see that little greater. It's probably the HER. I think that's the Hearst progression, and then some other ensembles, maybe the ARW. I know that was a little bit more aggressive on the instability, at least last when I checked. So, dew points, we'll take a look at the mean. Not expecting it to look anything too good. Again, that surface low pretty much extending northward, deepening with time as we get that divergence of the loft. Pretty much probably going to be bottoming out low 990, somewhere in the 990. And those dew points, upper 40s, maybe around 50, if lucky. I think this is pretty much an area you're gonna have to see what surface observations. Take a look at okay, we'll take a look at the raw plot, and pretty much over Texas, we pretty much see those 50 dew points pretty much already there. Pretty much at a decent distance really to go right now before pretty much extending up into Missouri, Illinois, into maybe Iowa. So, yeah, I think. Oh no, this was a little bit disorganized, but guess we got everything done we needed to. So, I guess that's it, and yeah, goodbye.